Hello students, hope you are doing great. I am Revan Siddhaya, your chemistry educator only at KLM Institute. Today's topic under chemistry is chemical reactions. So where can we see these chemical reactions? Only in labs? Not at all. We can see it in everyday, day-to-day activities like cooking, rusting of any iron, rusting of any metal for that matter. And every second as we speak, there are millions of chemical reactions happening in our body. That is respiration, digestion, and so on. There are a lot of chemical reactions happening in our body. So how do you know a reaction is a chemical reaction? To understand this, we'll see two small experiments. If you take magnesium ribbon and burn it under Bunsen burner, you can see here there is white powdered ash form. This is known as magnesium oxide, you guys. And if you can tell this reaction is converting magnesium in the presence of atmospheric oxygen to magnesium oxide. Let's see another experiment. In a conical flask, take zinc and sulfuric acid. When you put zinc and dilute sulfuric acid together, it forms zinc sulfate with production of H2 gas and little bit of heat. How do you know there is heat? If you touch the conical flask, you can feel the warmth of the conical flask. So by studying those two experiments, we can see the change in state, change in color, evolution of gas, change in temperature. If any of these four occur, it is a chemical reaction. So you cannot always tell the experiment completely. You can write it in short form, that is called equation. These are chemical equations. So the easiest way to write a chemical equation is word equation. You know the reactants and the products. So we'll write the reactants in the left hand side and the products in the right hand side. In between we put an arrow in the direction of the reaction. This gives us the direction of reaction. The plus symbol indicates that there are more than one reactant. If there are more than one products, yes, there would be a plus sign and the next product. So I think even this is too long for an equation. We already know the chemical formula of magnesium and oxygen. So Mg for magnesium, O2 for oxygen. Also MgO for magnesium oxide. But can you see there is something off in this equation? Yes, in earlier classes you might have studied that LHS should be equal to RHS. So let's count the number of atoms of each element. So magnesium in the LHS is 1, oxygen in the LHS is 2. Similarly, in the RHS, magnesium is again 1, but oxygen is 1, not 2. So this is something called as unbalanced chemical equation.
Register today at KLM Institute for free online classes, revisions, doubt clearance, private online and offline classes, Olympiad exams, and win prizes, scholarships, and much more.
So how do you write a balanced chemical equation? Let's see the previous experiment which we saw. So you know zinc is a reactant. So we write Zn, that is the chemical formula of zinc, plus dilute sulfuric acid, that is H2SO4, which gives H2 gas. It is already written here, H2 gas, plus it gives the reaction between zinc and sulfuric acid gives ZnSO4, that is zinc sulfate. So this is a balanced chemical reaction. How do I know it? Let's check. On the LHS, there is 1 Zn, H is 2, S is 1, oxygen is 4. So again, let's check the right hand side. So H here in the left hand side is 2, in the right hand side also 2. So H is balanced. So Zn is also balanced. There is only one Zn in the both sides, and S only one sulfur in both sides, and oxygen, there are 4 oxygen on the left hand side, also on the right hand side. So it is a balanced chemical equation. What do you do if you have given an unbalanced chemical equation? This is an example of unbalanced chemical equation. So here you can see Fe plus H2O is given, and these are in the reactant sides. In the product side, iron oxide, that is Fe3O4 plus H2 is given. Step 1, you can just box each of the elements here as shown. Yes, and next step, you can count the number of atoms of reactant and products. So Fe in the left hand side, that is in the reactant side, it is only 1. So write down 1 here, and in the right hand side there are 3 Fe, and hydrogen is 2, here 2 again. So oxygen molecules is only 1 here, and there are 4 number of oxygen atoms here. Okay, so let's see how do you balance such an equation. In the first step, you can first thing you can do is you can see which has the highest number of unbalanced atoms. That is the you can see here there are 4 oxygen atoms here, and there is only 1 oxygen atoms. To make it easy for you guys, I have put a table for reference. There is 1 on the left hand side, and there are 4 on the right hand side. So you can put down a similar table here, and in the reactant side there is 1, and in the product side there are 4. So what you have to do now, you have to bring 4 in the reactant side. You have to bring 4 oxygen in the reactant side. Where is oxygen in the reactant side? It is in the water molecule. So water molecules you can multiply by 4. Now you can get a perfectly balanced oxygen molecules. So there are 4 oxygen molecules on the left hand side and 4 oxygen molecules on the right hand side. So now that oxygen is balanced, we'll move on to the next step. You can see here when you multiplied water molecule by 4, you also increased the number of hydrogen molecules. Here it was 2 before, now it has become 8. But in the right hand side, it is still 2 because we haven't made any changes in the right hand side. So let's try to correct that. So initially now we have 8 hydrogens. Here we have 2 hydrogen. So to make an 8, how much do you need to multiply by 2? You can just divide 8 by 2, that is 4. You should add 4 in the right hand side, that is in the hydrogen part of the equation. So now both have, here you can see, both have equal amount of hydrogen and oxygen, both the sides. We are left with Fe. Fe is iron. So iron in the left hand side is 1. In the right hand side, in the product side, there are 3 iron. So you need to just multiply the reactant side by 3. So you can add 3 here. That is multiplication. You can write it neatly like this. This is a perfectly balanced equation. In the next step, you can just check the number of atoms in the reactants and in the products. Here Fe is balanced, hydrogen is balanced, and oxygen is balanced. Now you know how many atoms or how many molecules of each atom is taking place in a reaction. But what about their physical state? In what form are they in? You do not know about that. So we need to represent that also. Like you can write the symbols for that. You can see here I have mentioned a pretty small table. S for solid, L for liquid, G for gaseous, and AQ for aqueous. And here in the previous reaction which we balanced, here Fe is in solid state, water is in gaseous state, Fe3O4 is in solid state, and H2 is in gaseous state. Here you can see here H2O is considered as liquid most of the times. That is why we don't want to get into a confusion. We write gaseous G for the symbol. And for some reactions, we also need to mention the conditions. That is, here 340 atm is written. That is 340 atmospheric pressure is required to convert these reactants into products. Let's see another way of writing. This is catalyst, you guys. Above the arrow, if you write anything, that is the conditions. This is an example for condition, and this is example for catalyst. If these catalysts are not present, the reactants won't form into a product. So here is all you need to know about a chemical equation. This chemical equation can tell you more about the chemical reaction that is happening more than a simple word equation. That is why we mention all these things in the equation. So just recall, draw boxes around each formula, then list the number of atoms of different elements present in an unbalanced equation. Start balancing the equation with the compound that contains maximum number of atoms. We used which atom? Yes, oxygen. So start balancing the second atom. We used hydrogen. We did the third atom, that is the last atom, that is Fe. Then check the correctness of the balanced equation and write the symbols of physical states or conditions or catalysts if necessary. This is only done if it is necessary, guys. When it is normal temperature, normal pressure, and there is no catalyst involved, this step can be skipped. These are a few equations which you can try balancing at home. This is the first equation which you saw today. And these are other word equations which you can convert it into normal formulas. And these are formula equations which you need to balance. I have given all type of equations to balance, and please practice at home. And if you have any doubts, please recheck the video and feel free to comment down. Thank you. Hope you have a great day. All the best, students.